Quantiles. Quantiles are values at or below which a certain percentage of the observations lie. So let's have a look at the various forms of quantiles. The first one is a quartile. So what we do is we take the data set and break it down into 4 intervals. So then each interval would contain 25% of the observations. And naturally, 4 times 25% would be your 100% of all observations. A quintile, on the other hand, takes the data set and breaks it down into 5 equal intervals. Each one would, of course, contain 20% of the data. Decile breaks down the data set into 10 intervals. Each one would contain 10% of the observations. And finally, percentile breaks the data set into 100 intervals, with each interval containing 1% of the observations. So in all cases, you could see that they would fully account for all the observations. Now, tip, all quantiles may be expressed as a percentile. So for example, the third quartile is the same thing as the 75th percentile, or the 6th decile is the same thing as the 60th percentile. Now, the reason why this is important is as follows. Rather than having to become familiar with all forms of quantiles, we could just express all of them in terms of percentile and just really master the analysis of percentiles. And that's exactly what we're going to do in our illustrations. So first of all, to calculate the quantile, the first thing we need to do is we need to array the data set. And that's when you need quantiles, is to organize data. So the first thing we're going to do is we're going to arrange the data in order. And then step 2, we're going to find the rank of the observation using this following framework. So it's really just n plus 1, so the number of observations plus 1, times the percentile. And that's the tip that I was referring to. So we're going to express everything in terms of percentiles. And then once we've identified the rank of that particular quantile, then we could determine what its value is. So let's have a look at an illustration. Suppose that the data set, which has 10 observations, include the following observations. Now you could see clearly this is raw data because it's not in order. So the very first thing we have to do, and you could see me doing that here, is we have to rank the observations in order. So starting with the lowest number, which is minus 21, there it is, and ending with the highest number, which is 25. So then what we're going to do is we're going to rank the data, which is step 2. So there it is. Number 1 is the lowest, and number 10 is the highest observation, or the highest value observation. Okay, so now the data is organized and it's ranked. The only thing we need to do is we need to determine the value of the quantile. So in the first example, suppose that they ask us to compute the first quartile. So of course what we're going to do is we're going to convert this into a percentile. So the first quartile is the same thing as the 25th percentile. All right, so then we need to find the rank of that 25th percentile observation. In other words, here are the ranks from 1 to 10. So the question is, where does the 25th percentile lie in terms of these rankings? So that's the first thing we have to establish. So we use that framework. So we just take number of observations plus 1 times the percentile. So therefore, here's the way to read it. The rank of the 25th percentile is the observation between rank 2 and rank 3, specifically rank 2.75. So there it is. So this first quartile, its value is somewhere between the second observation and the third observation. Now here's the issue, right, ladies and gentlemen? I could see the second observation, I could see a third one. I don't see 2.75. So this is where we're going to use interpolation. And here it is. So I've reproduced those numbers that I just circled. So second rank is 8, third rank is 12. So then using these values, we need to estimate what the value will be for the 2.75th observation. So here's the way we do it. So obviously 2.75 will have a value that's higher than 8 and lower than 12. So our starting point is 8 right there. But then the question is, how far do you need to go into this line segment? So the line segment, the total line segment itself goes from 2 to 3. That's a whole unit, but we just need to go in 0.75. That's where you get this. And then the next question is, well, what's the value of that entire unit? Well, we're going from 8 to 12. So the value of that segment is 4. Now, 4 represents going from here to there, but I only need to go from here to there. So I don't need all of 4. I just need 0.75 of that 4, and that's exactly what we got there. So therefore, the value for the first quartile would be 11. And you could see how that fits into the framework, right? The second observation has a value of 8. The 2.75 has 11, and the third one has 12. So you could see the progression from each of these data points. And that's your answer, ladies and gentlemen. So how do we interpret this 11? 25%, because that's what you asked for, first quartile. So 25% of the observations have values that are equal to or below 11. And you can see that right here. So if we plot 2.75, which would be somewhere here, and our number was 11, and so that's what it says. It says 25% of all the observations, so 25% of everything, would have values that are equal to or less than 11. Now, in this case, we used a simple example, and that's why if you do a different approach, you may not necessarily get 11. But for large data sets, like if you're looking at hundreds and hundreds of observations, the framework we showed would actually give you the exact number for what the quantile is. But for all intents and purposes for the exam, this is the approach that you need to use. So let's do another illustration. Now we're asked to find the 8th decile. Of course, the first thing we're going to do is we're going to find the equivalent in terms of percentile. So the 8th decile is the 80th percentile. And remember what the interpretation is. I'll just jump the gun a little bit. It's the same thing as here, but now instead of 25%, that's going to be 80%. So we'll say 80% of the observations will have values that are less than whatever this quantile is. So it's this whole process is a way of organizing data, and this is often used, in some exams, like let's say GMAT or LSAT. They'll tell you what percentile you came in. So they'll tell you from the whole data set of all the candidate scores where your score fits in. Okay, so let's go through the process. First thing we have to do is find the rank. And we use this framework right there, n+1 times the percentile. So this would be the 8.8 observation. So since we have 10 observations, the 80th percentile would be the observation that's ranked 8.8. So now we have to find the value of that 8.8 observation. Well, I see an 8th observation, I see a 9th, I don't see 8.8. No problem. By using these polar ends, we can find an estimated value for the 8.8 observation. So let's do the process again. Now, right off the bat, we know that the 8.8 observation is going to have a value between 19 and 21. So again, we start with 19, and then we know it's going to be higher. Now, here's the thing. What is the value of this entire segment? It's equal to 3. Yeah, but what portion of that do you need? Well, I don't need the whole thing. I just need 0.8 of it, and that's right there. That's it. That is it. So then we add up those numbers. We get 21.4, and then again, how do you interpret this? 80% of the observations in our data set will have a value that's equal to or less than 21.4.